this region right here is really not actually flat and level. It actually is kind of sloped for a little bit of it. So what I can do here to mimic that effect, there's a few tools in our arsenal. One, all right, so this is the extrusion right here. It's called smaller half. Okay, all right. So one, when you extrude, you actually can draft. There's this draft option, and if you check it, notice what's going on here. It's like extruding it, and then it's just having an angle added. You can see that angle added on all sides. And if I make it, I'm going to make it a little more. If I make it 10, you can see it's making it bigger. Yeah. If I were to do -10, or maybe I need to just, no, I guess I get to just click the arrow. So you just click the arrow, makes it go the opposite direction. You can see it's like a tapering effect. Now, really easy to do. Very easy. You literally just click draft. The problem is, in many cases, if you're reverse engineering something, you're not measuring an angle. You're measuring sizes. So what angle would get this to shrink? You'd have to use, trig to do that, which is a lot of work. Also, the draft drafts everything on the extrusion. Do we see that? Which may or may not actually be what you want. In this case, it's definitely not what I want. Okay? So what I'm going to do with this smaller half, I am right here, it's got the faces and sketches, the regions to extrude. And if you notice, you can actually delete these. In fact, if you hover over them, you may not notice this, but if you look very astutely, okay, I'm hovering over this first one, and I don't know if you can see, but while I hover over it, instead of it being outlined in orange, it's outlined like in a yellowish green. And so if I hover over the middle one, I can actually see the middle. Watch this middle section. It's actually yellow when I hover over it, and I can just exit out of that. And so now I'm no longer extruding that. Now, that, I still have some work I want to do here, okay? But those two, I think, they come straight out, so I'll just extrude them. But this middle section, I'm going to do something a little different, okay? For this middle section, I'm going to use a loft. And a loft allows you to basically take one shape on one plane and another shape on another plane, and it does mathematics to sort of merge the first into the second. There's a limit on what you can do with that, but going from one rectangle to another rectangle is pretty trivial. Okay? So this was the smaller half. I actually have this sketch here called smaller half, all right, because I've already used it in the extrusion. It's grayed out. You can kind of see it, but you can click this eyeball and make it reappear. That sketch, I already have this smaller half, okay? You can turn it on or off. And then I have a plane right here to draw on. These are the tops of the shapes because I already extruded them. So I'm going to create a sketch on the top of one of these shapes. It doesn't matter which, okay? And I can draw, so I'm in a sketch. The sketch is on the top of this plane right here. I can draw a rectangle, a center point rectangle. That's narrower. And the idea is I will loft this old rectangle that I already drew, that's big, to this new one that I drew that's smaller. Now I do need to get a dimension for it. So let me get that. So we're looking at like 7.8 maybe. 7.5. 7.6. I'm going to go 7.6. So I can measure how wide that is. And it's thinner. It's definitely thinner than the part below. And I'm going to then do something here. I'm going to turn on this sketch. So I had this sketch called smaller half, right? And I'm going to actually turn it on so that it's visible in general. So I can see, I can now hover over and I can actually click on select this rectangle and click on select this rectangle. Make sense? Yes, yeah? Yeah? And now I'm going to do a loft. So the loft features right here. And it says profile. What profile should we choose? Well, the first profile I'm going to choose is this first rectangle. And the second profile I'm going to choose is this rectangle. Easy. And now I have it sloped. Now it's sloped. Exactly the way I want. Now, if you look at my table of contents over here, I'm going to move this sketch 1 and this loft 1. I'm going to move them to occur right after the smaller half. Why am I doing that? Because if I had done this, with hindsight, if I had done this initially, I would have made that sketch. I would have then extruded it like that. And then I would have made this new sketch. And then I would have done the loft. And what we can call this is we can call this like the smaller half top, maybe. And rename this other one the smaller half bottom. And then this extrusion, we'll call the smaller half sides. And the loft will be the smaller
Mr.
half.
Templeton,
Yes.
is Alex Baumgartner there?
Yeah, he's in the shop.
He is in the shop, okay. Does he typically do this every 7th period, every day?
I couldn't say he does it every single day, but he does do it on a regular basis.
Okay. He's always supposed to check in with his teacher, and he's not doing that, so I was just checking. Thank you.
No worries. So I'm going to call this the smaller half middle. And then you may notice that the fillets here might need to get adjusted a little bit. And I'm going to do that. Okay? I'm going to adjust the fillets. I'm actually not really sure what's going on with that. That looks a little crazy. But the smaller half outer fillets, those are the outsides. Then I have the inner fillets. And the smaller half inner fillets. So this would be an inner fillet thing. So I'm going to click on that. And I can hover over things and delete them. And then redo them. Where it's that yellowish green, that's the stuff that is wrong. Or that I want to get rid of. So I got rid of those. I'm going to go back in. So this was the inner fillets I did. I can now reapply those and have it continue. And in hindsight, I probably didn't have to actually delete them. I probably could have just added the new stuff. I hope what you've gotten out of this is that there's a value in naming your stuff intelligently. There's a value in breaking certain things up. Because when it comes to modifying or editing or tweaking later, you don't want to have to redo everything because the way you did it originally is not easily modifiable. To be honest, it wasn't that hard changing this part to be the way I wanted. But part of why it wasn't that difficult was because the way I sketched it and the way I organized all of my sketches and features and named it was conducive to changing it in the future. Do we have any questions? So we are done with this connector piece-ish. I'm not really sure that I want to try and tackle doing the actual clips. I didn't do it last year, and I don't know that I need to do it this year. But this is the only piece where I think I used a lot in the entire car. So I did want to at least do that change. So we are done now with the connector piece. Questions? Okay. So I'm going to go back to Onshape. And I'm going to make another document. So we have the passenger section. We have the connector piece. If I refresh it, maybe it'll update the preview, maybe. Trying to get it to update the preview. It might not. That's okay.
It's okay.
We will continue. What do you guys want to do next? I think I know what I did next last year. I think I did this plastic piece in here with the shapes. Since that fits in here, you want to do that? So we call this the passenger base because the little people, the passengers, fit in it. Okay? This is going to sound a little odd, but this might be the most important piece that you actually watch me go over and make. Because this is an exercise in basic geometry and constraint usage to get exactly what you want in a way that's easy to change, in a way that's easy to dimension, and a way that's easy to understand and, it actually works. So we're going to make this passenger base. Okay? So I'm going to click create. I'm going to choose document. It's not the most exciting piece, but this is actually, this is kind of really what CAD instruction does, is it gets you to make, good geometry, a good starting point. So we're going to make a sketch on the front plane. What shape do you think we should draw? Yeah. I would draw a rectangle. Now, should we use a center point rectangle or a corner rectangle? Okay. We can do that. So we have a center point rectangle. Now, I can't take that piece of plastic out. I can't take that out and actually measure the dimensions. But what I can do is I can measure the size of the hole, right? Yes or yeah? And assume that this is the same size. Or I could just go look up the size of the hole when I made the actual car, passenger section. So what I'm going to do here is I'm going to go look at this actual piece. So, top cavity. I can go look at the sketch. I can see I made it 50.3 wide and 40.6 tall. So I go here, 50.3, 40.6. Same dimensions as here. And they also made the radius of these fillets 5.5. So I can go to the fillet, and I can add a fillet to each of these four corners and say 5.5. Are we good so far? Now, you do you. But my recommendation, this is just me, I would just extrude this as is right now. And then I would cut holes for each of the shapes. That's what I would do. Some people don't like to break it up. They might say it's more efficient, it requires less things. But I don't necessarily think having less unique features or sketches is necessarily an advantage. It could be an advantage, but not necessarily an advantage. I think it really depends.
What size were your fillets?
I'm getting it to be about 8 millimeters. So I'm going to extrude 8 millimeters. So I have a base. So I'm just going to call this the base. Rename these to base. Questions so far? Okay. Now I'm going to actually draw the shapes. I'm going to do the shapes next. So I'm going to put a sketch on top of this. And I'm going to call this sketch the shapes, because that's what's on here. How many unique shapes do we see? How many different shapes?
Oh.
We have 4. Which one do you want to do first?
Square.
You want to do the square?
Get the easy ones out of the way.
Okay, I do think there's some intelligent thought there in doing the easy ones first. I think it's a smart choice. So we'll do the square. Okay, now, do we want to do a center point rectangle or do we want to do a corner rectangle for the square? You tell me.
Let's do a corner.
There is a correct answer here.
Oh, there you go. Who's right? Corner?
You know, take a look at your passenger base. The centers of the shape line up, don't they?
Mm-hmm. So center point.
So it would be advantageous to have a center for at least, really actually all 4, but definitely 3 of the shapes. So I'm going to do center point. I'm going to plop this over there. I'm not going to dimension to the center. But what I can do is I can dimension to the edges. And if I dimension it correctly, I will then be able to line up all of the other shapes center-wise fairly well. You'll see why in a moment. So what I'm going to do is I'm going to start dimensioning this. Now, I am going to have a hard time getting my calipers in there to measure those things. So what could I do instead? Huh? No.
Break the piece apart.
That would be better than nothing, but no. There's a very easy way I can get the exact dimensions of every single part of all four of those shapes. And it does not in any way, shape, or form involve using this.
Math. Previous years?
Nope.
Where you help? Like I keep math.
How did we get the overall width of that piece of plastic that we had no way of actually measuring?
You just took it from the sides.
So we used our brains and understood that since this piece of plastic fits in this hole, the width of the plastic is probably pretty close to the width of the hole, yes? So I want to start getting intricate dimensions for these four shapes that I have no way of getting to.
Brain's working already.
Oh boy. Oh boy. I'll give you a hint. You're not going to measure anything on here.
Divide.
The what?
Divide. Use math.
Are these holes just like there for fun?
Yeah. Oh.
You have all four shapes on the bottom of these people. So what I'm going to do is I'm going to measure the size of the square part of this person. I got 14.7. I'm actually going to just measure one part of it, and then I'll use an equal constraint because that's, it's a square. It's meant to be a square. Now, I am going to have to try and get some dimensions from this actual piece of plastic itself to get the relative placement, but I don't have to measure the size of the rectangle or circle or the star or triangle. So it is going to be a little tricky to get in there and do it. You might have to ballpark those. It's not ideal, but it's better than nothing. So you kind of just like look straight down and line it up. So I'm going to say that this top edge is 2 millimeters away. Not saying that that's right, but I don't know what else I can do. And then I'm going to do the same for the side. I'm basically just looking straight down with one eye and lining them up. And that one looks like about maybe 6.5. Maybe only 6. Yeah, I'm going to go with maybe just 6. So I have a 14.7 by 14.7 square. I use an equal constraint, so I only have to dimension one side. And then I put the top as 2 away, and the side is 6 away. Because I use a center point rectangle, I already have a center, correct? This is very easy to do the next shape. What shape should I do next? So I just draw a circle, and I'm going to already line up. I'm going to already line up the center of the circle with the center of the rectangle. If you're struggling to do that with a snap to, then what you can do is you can just deliberately draw a circle that has no snap to constraints, and then you can do a horizontal constraint. You can do a horizontal constraint to align the center of this circle up with the center of this square. Now, I am going to still have to dimension how far the circle is from the edge. We could also just assume it's the same. That is also a possibility. But I would measure the size of the circle first. Is the circle the same size as a square?
What's point?
Measure it, you tell me.
Okay.
Are they the same size?
Yeah.
I found them to be pretty much the same. So I'm going to make an assumption here that the distance to the edge is also probably the same. So I'm going to go with another 6. That was much easier to do because I already had the center, right? I already had the center. So I only have the dimension to one side. Okay? The next is the star. Oh boy. Are you all ready for this?
Totally.
You guys ready for the star? Are you ready? Maddie, are you ready? Are you ready to draw a star? Are you a star? Who's winning at Fortnite? Keegan or Nathan?
No. I'm not playing Fortnite.
Not Fortnite?
No, it's not. Not real.
That's lame.
Bryce
Bryce would be disappointed.
You'd rather us play Fortnite than actually doing schoolwork?
Oh, yeah. Yeah. Oh, sure. Yes, because we're actually doing schoolwork. So, how many sides does a star have?
5. And now?
So there's 5 points, right?
Yeah, I think so.
So what we're going to do is we're going to draw a pentagon. So right here, we have this inscribed and circumscribed. Just to see the difference, here's an inscribed one. I'm going to just draw it off to the side just to show you what it looks like. So here is an inscribed one. Okay. And here is a circumscribed one. What is the difference between the two? What do you see as the difference between the two?
On the outside one.
Yeah, the circumscribed, the circle goes around it. Okay? And the inscribed, the circle's on the inside. Make sense?
Yeah.
Yep. So I am going to draw an inscribed pentagon. So I'm going to go to inscribed. If it's not already selected, it's the first one. I'm going to go to inscribed, and I'm going to draw it. So I'm going to just, the first click places the center. The second click, broadly speaking, determines the size. And then you drag your mouse after that second click to kind of control how many sides there are. And I want it to be 5. So I have a pentagon. Do we have a pentagon drawn? Good. Now, the first thing I want to do is line up the center of the pentagon. So I'm going to use a vertical constraint. And I'm going to vertically align the center of this circle with the center of this pentagon. Good so far? Yes, say yeah? Second, I'm going to do a horizontal constraint. And I'm going to apply it to the bottom of this pentagon so that the bottom of it is flat. I'm going to move it up a little bit so it's not quite on the edge. Maybe make it a little bit smaller.
So what do you do?
I did a horizontal on this bottom edge so that that bottom edge is flat. The advantage of using this pentagon is when I do my points for the star, it's going to be much easier to make sure that each of them is more or less the same size. If I start with a pentagon, where the pentagon's already defined to have each side the same length and same angles and everything, it's a regular polygon.
Oh my goodness.
Are we good so far?
No.
What do you mean no?
Like, you won't let me move it without. Because you're already.
Well, I don't know if you drew it. Did you accidentally already have some?
I already have a string circle. Don't grab the middle point, grab the edge. So. Base is linear, mentioned dimensional base.
Okay. What we're going to do now is we're going to draw a circle. The reason why we're going to draw a circle is it's going to help us keep all the points to be the same distance from the center of this shape. So just trust in this. I'm going to take a circle and I'm going to draw it around like this. So I have a pentagon and I have a circle. We have questions thus far.
Hang on. No. I catch you up.
Well, what do you need?
So I don't want a vertical constraint at first?
I did a vertical constraint to line up the center of the circle with the center of the pentagon. I used a horizontal constraint to make this bottom of the pentagon flat.
Yeah.
Do we understand?
Yeah, but then whenever I try to move it,
Dude, just delete it and draw it again.
that's what I'm doing.
Well, if you need help, you bring your thing here.
Okay, it worked out.
Okay, so what I'm going to do now with this circle, now I haven't dimensioned anything yet, and that's okay. Just watch. I'm going to click the line tool. Gentlemen, hush. Gentlemen.
That's not true.
Gentlemen.
I'm sorry, this
Hush.
guy gets angry at
I don't care. Hush.
I don't care either. Nathan, stop.
So you're going to use the line tool, and you're going to draw your points. Now, when you draw them, they're going to go from a corner to the circle. Make sure that you don't have any snap to constraints like this accidentally being vertical or something being perpendicular. The only one should be this coincident constraint where it's just tied to being on the circle. Don't worry about them looking good. You just don't want to accidentally apply any constraints that you don't actually want. Again, make sure when you're drawing, pay very close attention. See right here, it might accidentally snap to making it horizontal. Don't do that. Okay? The only constraints I want are the coincident constraint. If you don't know what a coincident constraint looks like, that's one right there. And it literally just means that I'm placing this point on the circle. So it's forced to be on the circle. So I have drawn my 5 points. I have the basics of the shape already there. At this point, it's about using constraints and about using dimensions. Do we have questions before we move on?
No.
Okay, so now what I'm going to do is I am going to use constraints. What might be a good, easy constraint to help clean this up? Just using logic here. Something that you know has to be true.
Equal.
Equal. So I'm going to go to equal, right? And I'm going to set each side of each point equal to the other side of the point, right? Yeah?
Yeah.
In fact, watch what I do here. I click this one, and then I click this one, right?
Yeah.
Then I'm going to click this one, and click this one, then this one, then this one, then this one, then this one, and 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 this one and this one.
Wow.
So that makes them all the same size. And just doing that alone, literally, the only thing that I should have to do is dimension this. I shouldn't have to do anything else but dimension it. Now, what could I dimension? Well, there's a variety of things. By the way, I don't know if I mentioned this earlier, but when you dimension, a circle, you should always be grabbing it like this. If you try and grab it like this, there's no way to guarantee you're grabbing it at its fattest point. Whereas if you grab the circle like this, it's impossible to grab it at any point thinner than the full diameter.
What?
Okay? If you didn't know. But for this star, I could quite literally grab it like this. So, to kind of show you, if you can't see how I'm grabbing it, I'm going to kind of go up and try and show this. I'm grabbing it like that. So I have the teeth touching these 2 points. One tooth is like touching those 2 points, and the other tooth is touching this point. We understand? Maybe, possibly? Yeah? So when I grab it, the one tooth is touching 2 points, and then the other tooth is touching the point opposite. Now I got 15. Very close to 15. Measure it one more time. 15. So what I'm going to do is I'm going to actually dimension that. I guess I should delete these shapes over here. I don't need those no more. That was just for educational purposes. So watch what I do here. I'm going to take dimension. I'm going to click on this point right here. And I'm going to click on this point right here. And depending on where I move my mouse determines whether it's going to be the horizontal distance, the vertical distance, or this weird, distance that's like a straight line connecting them distance. I don't want it to be the horizontal distance, and I'll make that 15. Now, I can still change a lot of stuff here. I can still move it. It might be worth ballparking how far the endpoint is. It's like maybe 1.5, if even that, maybe 1.2. I don't know. It's pretty close to the edge, to be honest. That distance is pretty small. It's almost like 1. And that's it. I really want you to think about that. How many numbers did I actually put into making that? How many? I mean, I'm not going to count the 5. That's the pentagon thing. How many dimensions? 2. I mean, I got the horizontal location is centered based off of the circle above it, right? And I just placed this location, with this dimension right here. The only actual number I used to dimension the size of it is this. Everything else was done through constraints. So that finishes what we'll do.